Hello students, welcome to today's lecture on Theory of Machines. In today's lecture, we will start a new topic, that is CAM and follower. Under this topic, we will learn about what is a CAM and a follower mechanism, what we can do with this mechanism, what are its applications and its advantages. Then we will see the classification of each of the two components of this mechanism, that is classification of CAM and then the classification of follower. After classification, we'll learn about the various terminologies used in CAM and follower mechanism. And finally, we'll learn to draw the CAM profile that will ultimately drive a specified motion of the follower. This we'll do for various standard types of motions of the follower and also for different types of the follower in both in-line and offset positions of the follower. So let us start a discussion on CAM and follower. As we know, in kinematics of machines, we learn to analyze, achieve and control the motion of machine parts. And in this connection, we have studied various arrangements like mechanisms, belts and various types of gearings. Kinematically speaking, each of these gave us a specified input-output relationship, which are quantified in terms of velocity ratio. And except for gears, where we successfully kept it constant, it was difficult quantity to control. So here we are going to look at an arrangement which allows us not only to control velocity ratio but achieve a lot more than that. We will be able to control the displacement, the velocity, the acceleration as a function of time or a function of displacement of another machine part. The basic idea that we are going to use to solve these problems is very simple. Suppose we have been given a displacement against time graph which is to be achieved so that a machine part moves according to this function against time. What we do is we take this graph, we cut it on a thick metal plate and then the part which is to be moved according to this function is made to rest on this profile and is constrained with the help of some support so that it moves only up and down in the vertical direction. Now if we set this plate into uniform motion, the part which is resting on it will follow the displacement against time function that we are trying to achieve. As seen here, this metal plate with the particular profile is called the CAM and the machine part which is following is rightly therefore called the follower. So this is a CAM and follower mechanism and the CAM and follower constitute a higher pair. Generally speaking, so far in this course, we have studied planar mechanisms which consisted entirely of lower pair like revolute pair and prismatic pair. And now we will discuss about the higher pair mechanisms, by which we mean that there must be at least one higher pair in the entire mechanism. Higher pair means the two links are connected either along a line or at a point, as seen in this case. One such higher pair mechanism is included in this topic and we start a discussion with what we call CAM and follower system. In this CAM and follower mechanism, input link is the CAM and the follower is the output link. As we have already seen that CAM and follower mechanism is nothing but an exact function generator. By linkages we had approximate function generator, but by using this CAM and follower mechanism we can have exact function generator. Any complicated coordinate movement between the output and input link is possible by using CAM and follower mechanism, and which are widely used in various machines, particularly for timing purposes, as in case of moving valves of an IC engine. As we know, in an IC engine, the valves have to be kept open, first move to open it, then kept it open for some time, then move to close it, and then keep it closed for some time before opening it again. This is very well shown in this video. This is a camshaft over which the cam is mounted. This is the intake valve. This cam is actuating the opening and closing of the valve. So all these timing operations can be easily incorporated by using CAM and follower mechanism. The scope of our discussion will be limited to planar and two-dimensional CAM and follower mechanism. That is, all the points of the mechanisms will move in parallel planes So in a single projected view along the line perpendicular to the plane of movement will give you the true movement of the points of the mechanism. Having discussed about the cam and follower mechanism, let us now define cam. So cam is a mechanical element used to impart specifically desired motion to another element or to drive another element called the follower by direct contact. The cam may be rotating or reciprocating, whereas the follower may be rotating, reciprocating or oscillating. Now let us see some of the advantages of cam and follower mechanism. The cam and follower mechanisms are simple and inexpensive. Cam and follower mechanisms have few moving parts and occupy very small space. Follower motions having any desired characteristics are not difficult to design. When it comes to transferring rotary motion into linear actuation, there is likely no better mechanism than that of a cam and follower. Translating rotational motion into linear motion is not always the easiest thing to do efficiently. Cam and follower do this task with ease, but there also exists a subset of cam design that provide for a very fluid and precise motions. Cams are not limited by simple shapes, rather they can be designed to have an organic flowing interface with the follower mechanism. This results in more specified radial cams. It's this range of freedom in cam and follower design that gives engineers the ability to create unique mechanisms with only a simple rotational input. In any translation of motion, there is always some loss of energy. Cams will always have very minimum energy losses due to the fact that the interface between each part is such a small area, thus there is not a lot of friction. For these reasons, cam and follower mechanisms are used extensively in modern machinery. Cams are widely used in automatic machines, repeating machineries, IC engines, machine tools, printing control mechanisms, etc. They are manufactured by die casting, milling or punch press. So this is all for the introduction of cam and follower mechanism. I hope you have understood the utility of the cam and how the cam and follower mechanism work. In the next lecture, we will discuss the classification of cam. Thank you.